The celestial expanse, a canvas adorned with distant suns, has long served as a cosmic mirror, reflecting not merely the luminescence of stars, but also the profound yearning within those who cast their gaze upwards. For eons, humankind has peered into the heavens with a sense of awe, discerning faint patterns in the constellations, whispers of narratives lost to time. Yet, nestled within this breathtaking spectacle, lies a query so persistent it resonates across every civilization that has ever dared to envision possibilities beyond their terrestrial confines. Are we solitary beings in this vast expanse? The answer might not arrive through the conventional channels of intercepted broadcasts or the landing of extraterrestrial craft, but perhaps through a silent sojourner traversing our solar neighborhood, an envoy from an unknown origin. This visitor arrives unheralded, uninvited, seemingly unburdened by the gravitational pull of our world, a fragment of an alien realm, ancient beyond comprehension, gliding like a phantom between the planetary bodies. Astronomers categorize such entities as interstellar objects, celestial bodies not intrinsically linked to our sun, whose orbital paths trace extended open curves through our cosmic vicinity before dissolving back into the infinite void. Until remarkably recently, not a single such object had ever been documented. Our solar system was perceived as an isolated celestial island, its inhabitants perpetually tethered to the gravitational embrace of a single yellow star. However, in the year 2017, this ingrained perception was irrevocably fractured when an extraordinary object, seemingly tumbling from the profound depths of space, traversed our skies at an improbable trajectory. It was modest in size, devoid of discernible features, and emitted a faint luminescence. Yet its provenance was undeniably extraterrestrial, originating from the distant tapestry of stars. The discovery of this inaugural interstellar visitor, designated Oumuamua, awakened something primordial within the human psyche, the dawning realization that our solitude might be an illusion. For some, Oumuamua was merely another cosmic rock, a relic of distant worlds inadvertently ejected by cosmic chance. But for others, including a distinguished physicist named Loeb, it marked the inception of a far more profound inquiry. What if its nature was not entirely natural? This notion might seem rooted in the realm of speculative fiction, yet it finds fertile ground in the liminal space where imagination intersects with empirical data, the very frontier where scientific understanding expands. What if, among the countless fragments adrift in the interstellar medium, one carries the indelible mark of intelligence? What if the phenomenon observed in 2017 was not simply cosmic detritus, but something else entirely, perhaps a remnant of a civilization predating our own? Since that pivotal moment, each subsequent discovery of an object emanating from the interstellar darkness has arrived akin to a new stanza in an ongoing celestial poem. In 2019, a second traveler, unequivocally identifiable as a comet, provided confirmation that such visitors are indeed capable of reaching us. And now, another whisper emerges on the cosmic horizon. 3I Atlas. It is less luminous than its predecessors, smaller, and considerably more elusive. Nevertheless, it carries within it a promise, an opportunity to observe anew, to discern with greater clarity, to meticulously measure, to rigorously test, and ultimately a chance for profound understanding. For Loeb, this is not simply another cosmic stone. It represents a singular cosmic opportunity, perhaps the most significant humanity will ever encounter, to ascertain whether these interstellar visitors are mere products of natural cosmic forces or deliberate creations. The question, once met with derision, gains weight and significance with each new celestial revelation. The sky, once seemingly silent, now appears to murmur in response. Could it be that the cosmos is not indifferent? What if it is actively communicating, and we are only now beginning to attune ourselves to its language? The journey of Three-Eye Atlas, much like the delicate trace of a brushstroke against the night sky, may well become the most consequential message our species has ever received. However, to grasp its significance, we must first comprehend the path that led us to this critical juncture. How one individual dared to pose a question that the very edifice of science had seemingly overlooked. Thus, our narrative commences not with advanced technology or sophisticated telescopes, but with the most ancient spark within the universe: curiosity, that delicate flame that burns quietly within the minds of those who stare into the infinite, contemplating what unseen entities might be observing them in return. The silent communication from the stars persists, and amidst them a new voice has joined the grand celestial chorus. Faint, uncertain, yet undeniably present. Humanity listens, the cosmos awaits, and somewhere, perhaps beyond our immediate comprehension, something watches. Within the hushed academic corridors of Harvard University, beneath stained glass windows that cast an amber luminescence, a man sits enveloped by the immensity of profound thought. Books line the shelves, bearing the names of Einstein, Hawking, and Newton, each a mind that dared to push the boundaries of the known. Among them resides Avi Loeb, an astrophysicist whose intellectual curiosity burns with the same audacious intensity that once propelled Galileo to elevate his lens towards the heavens. For decades, Loeb has embodied multiple roles: a theorist of black holes, a scholar of the cosmic dawn, and an architect of thought experiments that bridged the infinite with the tangible. However, in 2017, as data began to stream in from a modest observatory nestled in Hawaii, Loeb's personal trajectory shifted towards a new and decidedly controversial direction. A visitor had entered our solar system, Oumuamua, and with its arrival, an unspoken question began to materialize. To the majority of astronomers, Oumuamua was an object of passing interest, an oddly shaped asteroid, perhaps a fragment of a shattered celestial body. It moved with unprecedented speed, its surface reflecting sunlight in peculiar, flickering hues. But Loeb perceived something else, hidden within the static of observational data, a signal of intent. He posed the question that few dared to voice: what if this was not a natural phenomenon? The scientific community was taken aback. For centuries, the concept of extraterrestrial intelligence had been relegated to the domains of science fiction and wishful thinking. The SETI initiative, once filled with optimism, had evolved into a cautionary narrative of false positives and profound cosmic silence. To even suggest the possibility of alien technology, particularly in a serious academic context, was to risk one's professional standing. Nevertheless, Loeb, undeterred, articulated his thoughts plainly in his scholarly articles and his book, Extraterrestrial: The First Sign of Intelligent Life Beyond Earth. He posited that perhaps Oumuamua was not of natural origin, but rather the product of intelligent design. This assertion ignited a firestorm of controversy. Many dismissed him as reckless, seemingly driven by a desire for media attention. However, Loeb's reasoning was not based on emotion, but on empirical evidence. The object's anomalous acceleration defied conventional gravitational explanations. Its form was unlike any known comet or asteroid. Furthermore, there was no observable evidence of outgassing or jets of vapor that could account for its unusual motion. Loeb proposed that the most straightforward explanation might be that it was artificial, a thin, reflective craft propelled by sunlight, much like a cosmic vessel drifting between the stars. For Loeb, this was not a flight of fancy, but a continuation of a profound scientific legacy. Galileo had faced ridicule for suggesting that the Earth orbited the Sun. Giordano Bruno had been subjected to persecution for contemplating the existence of infinite worlds. Albert Einstein had encountered skepticism for theorizing that time itself could warp. Loeb saw himself standing within that lineage of thinkers, believing that groundbreaking discoveries often commence as radical ideas, whispered within the halls of reason. He began to articulate his views publicly, not solely concerning Oumuamua, but also addressing a perceived malaise within contemporary science, a fear of embracing imagination. "We must permit ourselves to wonder," he stated in interviews. "Otherwise, we will merely discover what we anticipate finding." The media, in turn, amplified his name into headlines. Harvard astronomer suggests alien technology may have visited our solar system. But beneath the sensationalism lay something far more profound, a man grappling with the very limits of what science dares to question. Avi Loeb was not pursuing fantasies. He was advocating for intellectual humility. The humility to acknowledge that humanity might not be the first, nor the most advanced, intelligence to emerge within this vast and seemingly indifferent cosmos. His proposition was not a definitive claim of proof, but rather an earnest invitation to develop the necessary instruments, to gather the requisite data, and to be adequately prepared for the arrival of the next interstellar visitor. For if one had arrived, it was highly probable that others would follow. And then, the subtle whisper arrived. 3I Atlas. Another object, faint and ephemeral, its trajectory suggesting an origin from beyond our stellar neighborhood. To Loeb, it represented the next chapter in the same cosmic narrative, an opportunity to prepare, to rigorously test, and finally, to observe without preconceived notions. However, before the telescopes could be precisely aimed, and before the data could yield its secrets, a more significant confrontation was unfolding. A clash between the established order of scientific orthodoxy and an individual willing to risk his reputation for the pursuit of truth. Loeb's challenge extended beyond mere skepticism. It confronted the inherent inertia of intellectual thought itself. Because at the core of every significant discovery lies an act of defiance, the refusal to accept ignorance as a state of peace. And Loeb, standing beneath the echoing vaulted ceilings of Harvard, understood that the universe does not reward complacency. It rewards relentless curiosity. Outside, the sky transitions from azure to obsidian. Somewhere in the boundless expanse, 3I Atlas drifts, unseen, silent, unconcerned by the debates it has already ignited. But for Loeb, this moment holds a profound significance, the confluence of doubt and wonder, of ridicule and potential revelation. He does not claim certainty of his correctness. He simply recognizes the imperative for someone to ask the question, because at times, the most perilous idea in science is not that we are alone, but precisely that we are not. It began as a fleeting glimmer, a thread of light barely distinguishable from the pervasive hum of the cosmos. The Pan-STARRS telescope, perched atop the volcanic summit of Haleakala in Hawaii, first detected it. A small, rapidly moving celestial body traversing the sky at an unusually oblique angle. Initially, it went unnoticed. The automated algorithms flagged it as another near-Earth asteroid, one of the thousands that silently glide past our planet annually. However, upon tracing its orbital path backward, the mathematical models faltered. Its trajectory did not indicate a stable orbit around our Sun. It was not bound by our star's gravitational influence. It originated from elsewhere, following an open trajectory, much like a comet ejected from an alien system. It had entered our solar system, briefly experienced the Sun's warmth, and was destined to depart permanently. This was Oumuamua, the first interstellar object ever documented by humanity. Its name, derived from the Hawaiian language, signifies scout or messenger, and in many respects, it embodied both roles. Upon its initial appearance, scientists engaged in a frantic effort to characterize it. Was it a comet, an asteroid, or a fragment of a larger celestial body? Yet the more data they gathered, the more perplexing it became. Its velocity was exceptionally high, approximately 87 kilometers per second, far exceeding what could be explained by a mere gravitational slingshot effect. Its brightness fluctuated erratically, suggesting an unusual shape, perhaps elongated or flattened as it tumbled through space. And then, a truly extraordinary detail emerged. After its closest approach to the Sun, Oumuamua began to accelerate. This acceleration was not marginal but demonstrably measurable. Something was actively propelling it away from the Sun. In the established language of cometary behavior, acceleration implies a singular cause: outgassing. Jets of vapor erupt as solar radiation warms subsurface ice, acting like miniature thrusters. However, when telescopes focused on Oumuamua, no such phenomena were observed. There was no tail, no coma, no visible trace of vapor or dust. It was accelerating without any apparent propellant. The data was unequivocal. The object defied all prior expectations. For decades, astronomers had meticulously constructed a framework to explain celestial motion, gravity, inertia, thermodynamics, all consistent and predictable. Yet, here was an object that seemed to disregard every established rule. The scientific community responded with measured caution. Scholarly articles proliferated, and numerous theoretical models were proposed. Some hypothesized the sublimation of invisible hydrogen ice under solar radiation. Others suggested nitrogen flakes, akin to cosmic snow. A few entertained the notion of fractal dust or fragile exotic ices that would evaporate before they could be detected. Each theory strained the established principles of physics, pushing the boundaries of plausibility to their absolute limits. It was at this juncture that Avi Loeb re-examined the data and perceived what others seemed unwilling to consider. If natural explanations were becoming increasingly convoluted, why not entertain the most straightforward possibility? What if Oumuamua's acceleration was not driven by gas but by light itself? The pressure exerted by photons striking a broad, thin surface. And if that were the case, what if that surface was not a product of natural formation, but rather was engineered? This hypothesis ignited public fascination and academic consternation. The concept of a light sail, a wafer-thin structure, potentially a relic of alien technology, effortlessly gliding between stars, resonated with a sense of both absurdity and inevitability. as if the cosmos itself were attempting to communicate. The debate became intensely adversarial. Critics accused Loeb of sensationalism, yet others quietly conceded that no existing explanation accounted for Oumuamua's behavior with such elegant simplicity. For centuries, the essence of scientific progress had been defined by the inherent tension between skepticism and insatiable curiosity. However, in this instance, the question probed deeper, extending beyond a mere rock from space to the very core of scientific inquiry. Oumuamua vanished from view within a matter of weeks, leaving behind a legacy of more questions than answers. Humanity had caught a fleeting glimpse of its first visitor from another star, yet had failed to comprehend its nature. Nevertheless, that very failure fundamentally altered everything. For the first time, astronomers began to observe the night sky with a heightened sense of anticipation, consciously preparing for the arrival of the next interstellar traveler. Telescopes scanned with increased sensitivity, observational algorithms were refined, and the pursuit of cosmic messengers acquired a renewed sense of urgency. Somewhere beyond the orbit of Neptune, the spectral trace of Oumuamua continued its journey onward, a silent enigma lost to the profound darkness. But its impact lingered, reshaping our understanding of what is possible. It was no longer a question of if another such object would arrive, but rather when. And when it did, humanity would be ready. Or at least Avi Loeb would be. For within that faint streak of light, he had perceived a glimpse of destiny, the profound notion that the universe was not merely a void of random occurrences, but an intricate network of intention, awaiting our comprehension. Perhaps Oumuamua was not solely a messenger from an alien world, but a cosmic mirror reflecting our own civilization. A society still grappling with the belief that it might not be the first nor the last to gaze upward and ponder the unknown. In the years that followed the disappearance of Oumuamua, astronomers waited with an intensified sense of patience, their instruments meticulously tuned to the cosmic quiet. They had experienced the impossible and could not let go of that sensation. Somewhere within the vast darkness, another interstellar traveler was undoubtedly already en route, propelled by the chaotic forces of distant suns, traversing the immense void toward our small corner of the galaxy. Its arrival preceded expectations. In August of 2019, a Russian amateur astronomer named Gennady Borisov, while scanning the sky with a telescope he had constructed himself, a testament to passion rather than institutional funding, detected a blur where none should have been. An object streaked through the constellation Cassiopeia with an unusual velocity. Initially, it appeared to be another comet. However, as data poured in from observatories worldwide, an undeniable pattern emerged. This was no ordinary celestial wanderer. Its orbit was hyperbolic, much like Oumuamua's, open, eternal, unbound. Humanity had detected its second interstellar visitor. It was subsequently named 2I Borisov, in honor of the man who discovered it, and its existence solidified what many had begun to suspect. The galaxy teems with travelers. In contrast to its enigmatic predecessor, Borisov presented a more familiar profile. Through the keen eyes of telescopes, it revealed a luminous, gaseous coma and a trailing tail of dust, unmistakable indicators of sublimating ice. By all appearances, it was a comet, not an artifact of alien engineering, but a natural emissary from another stellar system. Yet, even in its apparent normalcy, it was extraordinary. This marked the first instance humanity had the opportunity to study an object formed under the influence of a different sun. Its chemical composition, its isotopic ratios, its observed behavior, all were shaped in a world light years away. Every molecule that evaporated from its surface carried information from an alien origin story, inscribed in frozen gas and the passage of eons. It was as if the cosmos itself had dispatched a postcard from another system, postmarked with eternity. For Avi Loeb, Borisov's arrival was a moment of both validation and stark contrast. Validation because it definitively proved that interstellar visitors are indeed real and not mere isolated anomalies. But a contrast because Borisov behaved precisely as one would expect a comet to behave, adhering to textbook physics, with no unexplained accelerations or hidden mysteries in its motion. It was nature exhibiting its most predictable characteristics. And so, the enigma deepened. If Tuai Borisov was a typical interstellar comet, then what exactly was Oumuamua? Two messengers arriving within a span of mere years, yet speaking entirely different cosmic languages, one whispering of chaos, the other of clarity. If both originated from the same fundamental process of planetary formation, why did one exhibit the characteristics of a comet, while the other defied all rational explanation? This paradox sparked a cascade of new theoretical frameworks. Some propose that interstellar space is densely populated with debris of diverse forms, shards of rock, sheets of ice, metallic fragments, each shaped by unique and cataclysmic events. Others speculated whether Oumuamua was perhaps a fragment of something far more ancient, something deliberately constructed. To Loeb, the contrast between the two objects was not a cause for dismissal, but rather a compelling invitation. When two travelers arrive at your doorstep, he wrote, and one speaks with clear articulation while the other communicates in riddles, one does not ignore the riddle, one listens more intently. The world's telescopes, in response, heightened their vigilance. Observatories from Chile to Spain began actively searching for more interstellar visitors, refining their analytical algorithms to detect even the faintest hyperbolic orbits before they slipped beyond reach. The hunt had become intensely personal, a subtle yet significant competition between the relentless march of curiosity and the unforgiving passage of time. And then, the third whisper emerged. In 2024, astronomers detected a dim, distant object within data collected by the Atlas Survey, an automated system meticulously scanning the heavens for potentially hazardous asteroids. Its motion was peculiar, its orbit unbound. Preliminary calculations hinted at a familiar yet profound truth. It was interstellar. They designated it 3I Atlas. Fainter, smaller, and moving at a higher velocity than either of its predecessors, it appeared almost fragile, a mere ghost within the vast dataset. For Loeb, this was the moment he had been anticipating with unwavering resolve since 2017. Another opportunity to observe, another chance to pose the question that had been met with such resistance. This time humanity would not be caught unprepared. New observatories, such as the Vera C. Rubin Observatory, were nearing operational status, equipped with the capability to capture the night sky in unprecedented detail. Algorithms, honed through years of dedicated searching, were primed to track even the faintest celestial streaks. Loeb's own Galileo project stood ready, its mission clearly defined: to test, to measure, to ascertain the truth. What Borisov had confirmed, Atlas might potentially reveal. And perhaps in its faint shimmer across the cosmic blackness, it would whisper the same extraordinary truth that Oumuamua had initially hinted at, that we are not the only hands to have interacted with the intricate machinery of the cosmos. Two visitors had arrived bearing profound questions. The third might potentially arrive bearing crucial answers. By the time the faint, almost imperceptible trace of 3I Atlas appeared within the data streams of 2024, humanity had already fundamentally altered its perspective on the celestial sphere. The enduring legacy of Oumuamua and Borisov had instilled in astronomers a cautious vigilance, a heightened awareness, and a deep sense of reverence. They now understood that space was not an impenetrable sealed vault, but rather a cosmic crossroads, a nexus where travelers from alien suns might traverse without prior warning. The Atlas system, the Asteroid Terrestrial Impact Last Alert System, had been conceived not for the purpose of discovery, but for the vital objective of planetary defense. It diligently swept the heavens each night, searching for rogue celestial bodies that might, at some point, pose a threat to our planet. However, on occasion, in its patient surveillance, it detected other phenomena, anomalies that did not belong to our solar family. Amidst the endless catalog of tumbling celestial stones, 3I Atlas stood distinct. Its orbital path was open like a portal left ajar between distant stars. Its velocity surpassed the gravitational grasp of our sun, and its luminosity, faint, flickering, and curiously inconsistent, drew the attention of a man already intently awaiting such a moment. Avi Loeb. He scrutinized the data with a level of intense focus that characterizes both dedicated scientists and evocative poets. For Loeb, Atlas represented more than a mere discovery. It was an answer to a fervent plea whispered 7 years prior, when Oumuamua had faded from view. The cosmos, he had once eloquently stated, rarely repeats itself. But when it does, it signifies a compelling imperative for us to listen intently. 3I Atlas was exceedingly faint, significantly dimmer than even Oumuamua. Nevertheless, its timing was impeccably opportune. Humanity now possessed superior observational tools, more sophisticated analytical algorithms, and a readiness born from a profound sense of regret. The Vera C. Rubin Observatory, nearing its full operational capacity, would soon be capable of capturing the night sky with a level of detail previously unimaginable. The Galileo project, established by Loeb, was now fully functional, its network of telescopes diligently scanning the heavens with custom-engineered software designed for real-time filtering, tracking, and classification of anomalies. This confluence of advanced technology and precise timing felt almost orchestrated, as if the universe had momentarily paused, affording humanity a second, critical chance to pose the correct question. 3I Atlas traversed the inner solar system in a slow, deliberate arc. Its motion was not as dramatic as that of Oumuamua. There was no sudden, inexplicable acceleration, nor any obvious, accompanying tail of vapor. However, its light curve, the rhythmic fluctuation of its reflected sunlight, suggested an underlying complexity. Certain frames hinted at a non-spherical form. Flashes of luminescence, unconnected to any predictable orbit, registered on the sensors. To a cautious viewer, it was mere signal interference. To Avi Loeb, it represented a prospect. The media once again focused their attention on him, recalling his prior pronouncements, the derision he faced, his steadfast resolve, and his unyielding patience. Now, as a new celestial body from beyond our solar system approached, journalists posed the same query they had years earlier. Do you believe this one might be artificial? Loeb offered no definitive affirmation, a stance he had never adopted. Instead, he offered a smile, a reserved expression that masked both awe and melancholy. I believe it would be presumptuous, he stated, to conclude otherwise. For Loeb, the concept of extraterrestrial ingenuity was not mere conjecture, but a working hypothesis, deserving the same rigorous consideration as any scientific model. When an object's trajectory defied the established laws of physics, it should not be disregarded simply because the explanation felt unsettling. To him, Oumuamua symbolized a profound truth. The universe might not only generate cosmic detritus, but also convey messages. And perhaps each interstellar visitor was a word within a grand cosmic lexicon, awaiting decipherment. To comprehend such communications, humanity required more than advanced optics. It demanded humility, a readiness to acknowledge its own cosmic insignificance without sacrificing its innate inquisitiveness. As Oumuamua's trajectory brought it nearer to the sun, scientists across the globe coordinated their observational efforts. The European Space Agency, NASA, and independent astronomical institutions collaborated with a hushed sense of urgency, aware that such transient visitors move with remarkable speed and vanish irrevocably once they pass. The slightest delay could forfeit the opportunity. Amidst the quiet exchange of data packets and spectral readings, Loeb perceived the outline of something far grander. He envisioned a future where humanity could discern patterns amongst these cosmic wanderers, not as random occurrences, but as a deliberate sequence, a grand design. He envisioned a civilization of such antiquity and immensity that its creations had become interstellar dust, drifting eternally, carrying the vestiges of intent across eons. If Oumuamua was such a vestige, then this precise juncture, this confluence of technological capability, intellectual curiosity, and moral fortitude, might represent the zenith of modern scientific endeavor. It was, as Loeb would later articulate, the most opportune moment in human history to apprehend the truth concealed within motion. And somewhere between the ambient hum of scientific apparatus and the stillness of the night, the cosmos appeared to concur. The laboratory lights dimmed as dusk settled over Cambridge. On the display screens at the Galileo Project's command center, the sky blazed with stars, each a pinpoint of ancient fire, each a potential revelation. In the profound quietude, machinery whirred, telescopes adjusted their focus, and sophisticated algorithms commenced their ceaseless task of searching, sifting, and learning. Avi Loeb stood at the epicenter of it all, observing not merely data but the nascent form of destiny. The Galileo Project was his rejoinder to prevailing skepticism. Where others saw mere speculation, he identified a methodological deficit. If we are to discover evidence of extraterrestrial technology, he frequently asserted, we must actively seek it rather than encountering it by chance. Consequently, he established the inaugural systematic scientific endeavor dedicated to the search for alien artifacts in Earth's vicinity, eschewing whispered conjecture or clandestine government intelligence in favor of open, meticulous observation. Its objective was unambiguous: to apply the same disciplined approach utilized in studying galaxies and black holes to the pursuit of what he termed techno-signatures, observable indications of technology not of human origin. Unlike radio SETI, which focused on detecting distant signals, The Galileo project aimed to visually confirm the presence of objects, fragments, or patterns in the sky that unmistakably indicated artificial construction. It began modestly. Compact telescopes, high-resolution cameras, and machine learning systems designed to identify anomalies in real time. Subsequently, partnerships were forged. Collaboration with NASA scientists, support from private benefactors, and data-sharing agreements with observatories worldwide. This was not a quest for alien beings, but a pursuit of intellectual integrity in the face of profound uncertainty. Yet, beneath its scientific rigor, pulsed a profoundly human emotion: wonder. Loeb often drew a parallel between his work and that of Galileo. Galileo's initial telescopic observation of Jupiter's moons in the year 1610 shattered established dogma, proving that Earth was not the singular center of all celestial motion. The Church subsequently condemned him for this revelation. Centuries later, Loeb found himself in a comparable predicament, navigating the tension between prevailing knowledge and ingrained apprehension. "Science advances," he wrote, "not through consensus, but through courage." For some, the Galileo project bordered on sacrilege. It dared to investigate the unthinkable, the possibility that alien artifacts might reside within the operational range of human instruments. However, Loeb's brilliance lay in rendering the extraordinary amenable to empirical investigation. Every data frame, every luminous pattern was meticulously catalogued and rigorously tested, subjected to the same exacting scrutiny that governs planetary science or astrophysics. The ultimate aim was not to definitively prove the existence of extraterrestrial intelligence, but to establish the legitimacy of the question itself. Now, with the approach of Oumuamua, the project's moment had arrived. Across the globe, telescopes synchronized their collective gaze. The Vera C. Rubin Observatory prepared to conduct vast sky surveys, generating terabytes of observational data each night. Infrared sensors, radar arrays, and spectroscopy networks were meticulously aligned. The Galileo project's cameras, sleek, rapid, and unblinking, lay poised to capture a faint shimmer that could fundamentally alter our understanding of the universe. For Loeb, this celestial alignment possessed a poetic resonance, a union of human ingenuity and cosmic opportunity. It felt as though the universe itself had extended an invitation, a third visitor arriving precisely when humanity had cultivated the capacity to observe with purpose. However, this investigative pursuit encountered considerable opposition. Certain scientists derided the endeavor, dismissing it as a sensationalized publicity stunt, cloaked in academic pretension. Others accused Loeb of blurring the boundaries between scientific inquiry and fanciful storytelling. Yet he pointed out the inherent irony. Skepticism itself necessitates supporting data, and data was precisely what he sought. "If you doubt me," he remarked calmly in interviews, "then look through the telescope yourself." And perhaps therein lay the essence of his philosophy, that in science belief holds no sway, only observation matters. The cosmos remains indifferent to our egos, demanding only our focused attention. In his writings, Loeb frequently likened the search for extraterrestrial technology to an act of listening, not for spoken words, but for a discernible presence. The universe, he posited, is an immense cathedral, and we are deafened by our own internal clamor. The initial step toward discovery is silence. That silence now enveloped the Galileo laboratory like a sacred interlude. Screens flickered, meticulously recording the stately progression of the stars. Somewhere amongst them, perhaps, resided Oumuamua, minuscule and faint, yet bearing the immense weight of every existential question ever posed. If this celestial object proved to be a natural phenomenon, science would advance its understanding. If, however, it revealed itself to be an engineered entity, humanity would undergo a profound awakening. In either scenario, the universe would communicate. And so the telescopes maintained their tireless vigil, their fidelity unwavering, because in a cosmos replete with silence, every subtle whisper carries profound significance. In that chamber, bathed in the gentle luminescence of monitors, one could grasp the palpable truth of Loeb's conviction that the very act of searching possesses an inherent sanctity, and that curiosity represents humanity's most ancient form of supplication. The Galileo project was not conceived to locate extraterrestrial beings. It was established to remind us that our capacity for attentive observation persists. The spectral image of Oumuamua continues to linger in the annals of astronomy, not for what it definitively explained, but for what it obstinately refused to elucidate. It presented an enigma that persists like a dream, incomplete, disquieting, and luminous. When astronomers attempted to reconstruct its form from the faint light it reflected, the deduced shape appeared almost surreal. It was not spherical, nor remotely close. Its brilliance fluctuated dramatically, suggesting an elongation 10 times greater than its width, or perhaps even more attenuated. Some models posited a cigar-like configuration, tumbling erratically as it traversed space. Others envisioned a flattened disk, akin to a shard of cosmic metal, spinning languidly under the sun's rays. Both hypothesized shapes deviated markedly from established celestial geometry. No asteroid, comet, or previously observed fragment exhibited such characteristics. Yet it was not solely its form that defied comprehension. It was its motion. After executing a gravitational slingshot maneuver around the sun, Oumuamua accelerated with a gentle, persistent force that seemed to counteract the pull of gravity. It was as if an unseen influence had imparted a subtle nudge, a faint whisper of applied power. However, no evidence of cometary outgassing was detected. No tail, no vapor, no discernible trace of the invisible hand that propelled it. To account for this anomaly, scientists developed increasingly unconventional explanations. Could it have been composed of pure hydrogen ice, sublimating invisibly into space? But hydrogen would have dissipated long before reaching our solar system. Could it have been nitrogen ice, similar to the surface of Pluto? This would necessitate an implausible abundance of nitrogen-rich planetary bodies scattered throughout the galaxy. If it were a collection of dust particles, a porous, loosely aggregated structure, it would have been disintegrated by solar radiation pressure. Each proposed theory crumbled under the weight of its own inconsistencies. Loeb's interpretation, that it was a remarkably thin, reflective sheet, required no such extraordinary assumptions. Sunlight alone could have provided the subtle acceleration, provided it was less than a millimeter thick and as wide as a football field. This explanation, he contended, precisely matched the observed data. But what natural process could generate such an object? None were known. It was too fragile to withstand interstellar collisions, too delicate to form from the typical remnants of shattered celestial bodies. Its reflectivity was exceptionally high, its rotational behavior unusually complex, and its origin remarkably precise. The naturalistic explanations strained the bounds of imagination. The artificial ones simply demanded intellectual courage. For Loeb, this was not a leap of faith, but a logical progression. "When you hear hoofbeats," he wrote, "you typically think of horses. But if you find yourself on an alien planet, perhaps you should consider the possibility of zebras." The universe, after all, had presented unexpected phenomena before. He was not asserting definitive proof, but merely the logical inference of possibility, the most conservative stance a scientist can adopt. Nevertheless, the scientific community reacted with unease, not because the data contradicted their beliefs, but because the implications did. If Oumuamua were indeed artificial, it would signify the existence of intelligence beyond Earth, an intelligence possessing technology capable of traversing interstellar space. It would imply that humanity was not the pinnacle of creation, nor even the first to navigate the cosmic ocean. Within academic circles, ridicule served as a defense mechanism. It was easier to laugh than to confront the unsettling implications. Yet, the numerical data remained stubbornly resolute. Subsequent analyses suggested that Oumuamua's light curve might align more closely with a flattened, disk-like form, perhaps a shard or a sail. Its observed acceleration was consistent with sunlight exerting pressure on a thin surface. Its trajectory suggested a deliberate path, as if it had been purposefully propelled rather than randomly flung. Loeb described it as the shape of the impossible. Yet, if such shapes exist, what purpose might they serve? Perhaps it was a discarded fragment from a long-lost probe. Perhaps it served as reconnaissance, akin to a buoy marking interstellar routes. Or perhaps it was neither, but an artifact from a civilization long extinct, drifting through the Milky Way like a fossilized idea. Even its detractors conceded, if one such object exists, more must follow. Nature does not create unique instances. And so, with the arrival of 3I 2023A3, Tsuchinshan Atlas, the stage is once again set. The fundamental physics remain the same, as does the mystery, but this time humanity possesses sharper observational tools, more sophisticated instruments, and a greater willingness to perceive. What makes Oumuamua unforgettable is not its enigma, but its reflection, not of light, but of our own scientific soul. It compelled humanity to confront its limitations, to decide whether fear or curiosity would shape its perception. For sometimes the most terrifying shape in the universe is not what we can see, but what we cannot explain. And as 3I 2023A3, Tsuchinshan Atlas, draws nearer, the question reemerges with the force of an incoming tide. What if that shape was not a product of natural chance, but a signature of intentional design? Radiation represents the gentlest of forces, and the most ancient. Every photon emanating from the sun carries a subtle pressure, an almost imperceptible push. Over eons, this pressure sculpts comet tails and stirs cosmic dust. To the human eye, it is imperceptible, but to the appropriately designed object, thin, lightweight, and deliberate, sunlight transforms into a means of propulsion. Avi Loeb understood this intimately. If Oumuamua's acceleration stemmed from radiation pressure, then it was not being propelled by gas or ice, but was being carried by light itself, a cosmic vessel navigated by the same physical principles that drive a comet's tail, only refined with exceptional precision. This concept was not mere fantasy. Humanity itself had begun to explore this very principle. In the year 2019, the Planetary Society's LightSail 2 mission successfully deployed a reflective mylar sheet into Earth's orbit. Each particle of sunlight exerted a tender pressure upon it, and over several days, the craft began to move. It possessed no engine, no fuel, only the persistent, unwavering influence of photons. This vision had persisted since Kepler, who once mused that celestial vessels might one day traverse the heavens propelled by cosmic winds. Now, in the era of data analysis, that dream had begun to manifest. Loeb posed the question that others avoided. What if another civilization engineered theirs long before us? He contemplated civilizations vastly older than our own, whose scientific advancements were no longer constrained by the limitations of conventional fuel. For them, a light sail would not be merely technology. It would be an art form, an extension of physics itself, a gossamer sheet of engineered material, perhaps metallic or composite, vast enough to capture the pressure of starlight and ride it across interstellar expanses. If such civilizations existed, their discarded materials, the remnants of failed missions, abandoned probes, or defunct sails, would still be drifting in the void. Time erodes all things, but not instantaneously. A sail might endure for millions of years, folding, tearing, and fading until one day it drifts into another star system like ours. The mathematical probabilities aligned. A thin sheet, less than a millimeter in thickness, with a density 1,000 times less than that of rock, would behave precisely as Oumuamua did. It would accelerate just enough to match the observed deviation. No jets, no outgassing, no need for miraculous intervention. The light sail hypothesis correlated with the observed data with unsettling accuracy. Yet, to accept this hypothesis would necessitate a rewriting of the narrative of cosmic solitude. It would mean acknowledging that the evidence might already be present, disguised within its geometric configuration. To Loeb, this possibility did not constitute proof of alien existence. It was evidence that science had become overly cautious. When a theory aligns with the data, he stated, we must not dismiss it simply because it evokes discomfort. His peers invoke the principle of extraordinary claims require extraordinary evidence, using skepticism as a shield. Loeb countered that skepticism devoid of curiosity leads to stagnation, and that history favors those who dare to inquire. The notion of a light sail traversing the solar system carried a profound poetic resonance. It implied great age, immense patience, and the enduring persistence of design across unimaginable timescales. Perhaps its creators were long gone. Perhaps they had dispatched it eons before humanity's emergence, a silent gesture across galactic distances. Or perhaps it was never intended to be detected, merely debris, akin to the relics of human satellites that now orbit Earth as silent memorials. If Oumuamua was one such fragment, then 3I 2023A3, Tsuchinshan Atlas, might be another. And this time humanity might succeed in observing it before it vanished. Telescopes were positioned to measure polarization, detect reflections, and map its surface texture and albedo. If Atlas exhibited the same shimmering irregularities, the same telltale response to light, the case for an artificial origin would strengthen considerably, moving beyond anecdotal conjecture. Even the skeptics observed with keen interest. In the quiet corridors of observatories, scientists who had once ridiculed the concept now adjusted their lenses with silent anticipation. They had not yet embraced the idea, but they were eager to ascertain the truth. Light sails are more than mere metaphors. They are promises that the universe rewards perseverance, that the faintest impetus can carry one across the immensity of space. For Loeb, they embodied the quintessential aspects of scientific pursuit: vulnerability, daring, and grace. As 3I 2023A3, Tsuchinshan Atlas, approached the Sun, the possibility shimmered once more. Perhaps this too would prove to be a natural phenomenon, another frozen mass of rock and ice. Or perhaps, in the gentle play of sunlight upon its surface, humanity would glimpse something familiar, a signature of intent etched in light. Because if radiation pressure could propel a sail, then perhaps for the first time it was not merely the sun exerting force, but something, somewhere, that had once set it free. In the deep hours preceding dawn, the observatories stir to life. Domes slide open like mechanical petals, revealing intricate instruments of glass and steel that turn expectantly toward the approaching celestial visitor. Across continents, from the Atacama Desert in Chile to the volcanic peaks of Hawaii, telescopes pivot in unison, their movements slow, deliberate, and almost reverent. Humanity awaits. 3I 2023, A3, Tsuchinshan Atlas, glides through the darkness, faint as a dying ember. Its orbital path is traced not by direct observation, but by precise calculation. It is no longer merely a data point. It is a target, a chance to redeem every enigmatic mystery that slipped away with Oumuamua. This time, humanity will not avert its gaze. Avi Loeb has stated it frequently. The key to discovery is preparation. When the next interstellar object appears, he wrote, we must be ready not only to observe it, but to intercept it. That readiness is now unfolding across the globe. At Harvard University, the Galileo project refines its predictive models, mapping the trajectory of Atlas with surgical accuracy. Its network of small telescopes is primed to record its passage across multiple spectral bands: visible light, infrared, and radar. Each instrument, akin to a nerve ending within a vast sensory system, will gather fragments of truth. Meanwhile, the Vera C. Rubin Observatory prepares for its initial operational phase. Its 8.4-meter mirror and 3.2 gigapixel camera, representing the most powerful sky survey instrument ever constructed, will scan the night sky with such unprecedented speed that no interstellar traveler will again pass unnoticed. Its data pipeline, processing information in real time, will detect fluctuations in brightness, measure elemental composition, and even reconstruct surface geometry. Elsewhere, the European Southern Observatory readies its Very Large Telescope to capture high-resolution spectral data, splitting light into its elemental fingerprint to reveal whether Atlas contains metals, silicates, or something more exotic. The James Webb Space Telescope, positioned distantly and operating at cryogenic temperatures in its L2 orbit, is scheduled for brief observation windows. Its infrared sensors possess the capability to detect faint thermal signatures that might indicate the presence of unusual materials. For the first time in recorded history, the world's scientific instruments are acting in concert. The collective endeavor is not solely astronomical. It is profoundly emotional. Every scientist at every terminal experiences the same quiet yearning, the same deep-seated desire to witness something unprecedented, to perceive a hint of purpose within the vast expanse of the void. Some are driven by the pursuit of recognition, others by the quest for truth, but all, in their own fashion, are searching for a sense of belonging, for home. Loeb's vision extends further. He proposes something even more audacious, a mission of direct interception. With sufficient advance warning, he argues, a small probe could be launched to rendezvous with an interstellar object as it traverses our solar system, allowing for close-up photography and perhaps even the collection of dust samples. NASA's Innovative Advanced Concepts program has taken notice. Conceptual designs are being sketched for Project LAR, a mission designed to pursue such objects utilizing high-velocity propulsion systems, thereby transforming speculative inquiry into direct empirical engagement. But for now, humanity watches. 3I 2023A3, Tsuchinshan Atlas, glides silently, its brightness oscillating in an unusual rhythm, the same erratic pulse that once characterized Oumuamua. Data streams in line by line as observatories transmit their measurements through networks humming with palpable anticipation. The object's surface reflects sunlight in a pattern far too complex for a simple sphere. There are fleeting moments of intense glint when its reflection spikes sharply, as if a flat facet had momentarily captured the sun's rays. This could be mere coincidence. It could be a consequence of its geometric shape, or it could signify something else entirely. The scientific teams meticulously analyze, debate, and cross-verify their findings. No one is eager to rush to premature conclusions, not this time. Yet beneath their ingrained caution, a flicker of hope ignites. The light emanating from Atlas is steady, yet unpredictable, a paradox that challenges the very limits of reason. In interviews, Loeb maintains a composed demeanor. "This is the most significant opportunity we have," he assures the press. "If Atlas reveals even a single anomaly inconsistent with a natural origin, we will be compelled to reevaluate our place within the cosmos." Beyond the surface of his pronouncements lies a profound call to action, not a declaration of absolute knowledge, but an entreaty to re-examine, to engage more deeply, and to reject complacency born of ignorance. The planet continues its celestial journey under the impassive watch of our creations. The torrent of information persists. Figures flicker across displays, arrays of intensity, modulation, and luminosity. Hidden within this digital cascade might reside the initial sign of extraterrestrial artistry, or perhaps merely statistical noise. The truth remains elusive, and it is this very uncertainty, more than anything else, that sustains them through the extended, star-filled nights. For in this era of skepticism and rigorous calculation, the very essence of wonder might have become the most precious commodity, the rarest find of all. From the arid expanses to the towering peaks of our world, instruments awaken with the arrival of darkness. They perceive not through auditory senses, but by employing reflective surfaces. Light, faint and originating from eons past, descends from the firmament, diffused by interstellar dust, refined by our atmosphere, and captured by impeccably polished glass. Each individual particle of light carries a hidden truth, the unique signature of an entity that defies conventional understanding. 3. Designated I, Atlas, the third emissary, traverses the periphery of human comprehension. Its signal, though weak, is undeniably distinct. Each night the data coalesces into small, invaluable fragments, points of illumination that, when meticulously assembled, begin to convey a narrative. The cosmos, with its infinite patience and unhurried pace, is unfolding a story. At the core of this cosmic chronicle lies the symbiosis of our sophisticated machinery. These are the monumental optical instruments humanity has erected to discern the imperceptible. The Vera C. Rubin Observatory is now operating at its full operational capacity, meticulously surveying the southern celestial hemisphere in a steady, rhythmic pattern. Its extraordinary 3.2 gigapixel camera captures the entirety of the celestial dome every few nights, generating an immense volume of information, 20 terabytes each morning. Within this vast digital ocean, Atlas emerges as a solitary, drifting mote, a faint voyager traversing an endless expanse. The observatory's sophisticated analytical programs identify its motion, quantify its luminescence, and map the subtle fluctuations in its light intensity. Preliminary investigations indicate an unusual degree of consistency. It exhibits a rotation, yet it is not uniform. Its brightness surges, subsequently diminishes, and then surges once more. This rhythmic oscillation cannot be solely attributed to random disorientation. Its form or surface composition suggests an interaction with light that deviates from typical curvature, as if the photons are reflecting off planar surfaces. Concurrently, the telescopes of the Galileo project meticulously monitor the object each night from their observation posts in the northern hemisphere. They conduct observations across a spectrum of visible, infrared, and ultraviolet wavelengths, comparing the reflected light to the characteristics of known materials. Metallic compositions produce sharp reflections. Carbonaceous rock, conversely, scatters light diffusely. The findings are perplexing. Atlas displays a composite of both characteristics. At certain junctures, its reflectivity approaches that of highly polished metal. At other moments, it darkens to the point of near invisibility. R.V. Loeb examines the graphs in profound silence. He has encountered this particular pattern previously. In the year 2017, a similar erratic fluctuation in brightness defined Oumuamua, the light signature that betrayed its remarkably thin and flat structure. If Atlas shares that distinct characteristic, the implications are monumental. It would signify not one, but two celestial bodies, originating from beyond our solar system, exhibiting attributes incongruent with natural cosmic phenomena. Two distinct data sets, separated by several years, converging upon the same improbable reality. To the uninitiated observer, these are merely numbers. To Loeb, they are faint intimations of intentional design. At NASA's Goddard Space Flight Center, sophisticated infrared spectrometers analyze the reflected wavelengths. They note the absence of characteristic cometary ices on its surface. There is no sublimation, no visible jets, and no volatile elements present. It behaves, once again, in a manner akin to Oumuamua, cold, arid, and entirely unaffected by solar radiation. Meanwhile, within the European Space Agency's data processing facilities, an advanced artificial intelligence algorithm, trained on countless examples of known asteroids, attempts to categorize it. The model exhibits hesitation, its probability index wavering between various classifications. In computational terms, it is unable to definitively ascertain the nature of Atlas. This is the precise juncture where scientific inquiry teeters between profound wonder and stark disbelief. The more data that is acquired, the less nature alone seems capable of explaining it. The more precise the numerical correlations become, the more unsettling the implications grow. The Galileo project responds with its customary methodology: more observation. Their telescopes are outfitted with polarization filters designed to analyze how light disperses from surfaces, as natural rock and manufactured materials polarize light differently. The results indicate unusually high polarization angles, suggestive of a smooth, perhaps even highly reflective surface. Loeb's annotations are characterized by their calm, almost detached tone, yet beneath the surface of the scientific language, a palpable sense of awe can be perceived. He meticulously documents the unexpected coherence in reflectance, the asymmetry of its surface properties, and its overall composition, which is inconsistent with the random aggregation of particulate matter. The vernacular of science remains dispassionate, but the underlying sentiment is one of burgeoning excitement. Nevertheless, Loeb remains acutely aware of the imperative for caution. A single anomalous object could be attributed to error. 2 could be a mere coincidence. But 3 interstellar visitors defying all expectations would necessitate a fundamental re-evaluation of our understanding. The available data, though incomplete, strongly suggests a discernible pattern. Publicly, Loeb exercises restraint from making definitive pronouncements. He communicates to journalists that the evidence must be allowed to speak for itself. Our sole recourse, he maintains, is to listen attentively. However, within the scientific community, a palpable tension begins to escalate. The boundary between judicious skepticism and outright denial starts to erode. The most unsettling yet straightforward explanation is that we are in fact witnessing evidence of technology originating not from Earth, but from somewhere else entirely. Should Atlas prove to be what Loeb suspects, it will not only fundamentally alter the landscape of scientific understanding, but also necessitate a complete rewriting of humanity's perception of itself. The celestial expanse will transform from a silent backdrop of enigmatic mysteries into a meticulously detailed map of potential neighbors. Consequently, the instruments persist in their unwavering vigil. The Rubin Observatory continues its methodical scans, and the Galileo telescopes diligently record their findings. The James Webb Telescope listens in the silent realm of infrared, capturing faint thermal echoes. Each photon collected represents a thread in an ever-expanding cosmic tapestry. And within this intricate fabric, a distinct form is beginning to emerge, not one composed of rock or ice, but of deliberate intention. Perhaps, as the light from Atlas ultimately recedes, humanity will be left not with definitive answers, but with a question so profound that it cannot be ignored. If something beyond our world possessed the means to construct vessels capable of traversing the interstellar void, then perhaps they too once gazed outward, much as we do now, and pondered whether another intelligence awaited them at the destination. At its very core, science is not an impenetrable fortress of established facts. It is rather a delicate bridge, spanning the chasm between doubt and conviction. Every mathematical formulation relies on a fundamental belief in the integrity of data. Every breakthrough is predicated on the courage to challenge existing paradigms. Yet, few frontiers expose the precariousness of this bridge with such vivid clarity as the persistent search for evidence of extraterrestrial intelligence. By the time that 3i Atlas became the focal point of nightly observations, the atmosphere surrounding the discourse had become charged with anticipation. The tension was not merely intellectual. It carried a profound emotional weight. Scientists, journalists, philosophers, and visionaries alike found themselves standing at the precipice of the extraordinary, on the verge of what lay beyond the limits of the imaginable. R.V. Loeb navigated this precarious edge daily. To his detractors, he was an instigator, a provocateur, exploiting mystery for personal acclaim. To his supporters, he represented something far rarer, a scientist willing to stand resolutely against the prevailing currents. His work had revived a question that contemporary astrophysics had quietly relegated to obscurity beneath a veneer of precise measurement. It was a question as ancient as the human capacity for wonder itself. What if we are not alone in this vast universe? Within the scientific community, the division widened. One faction adamantly asserted that science must rigorously protect itself from unfounded speculation, deeming the invocation of alien technology without incontrovertible proof to be an act of recklessness. Another faction, however, quietly argued that true recklessness lay in silence, in the deliberate disregard of anomalies, in the suppression of data that did not conform to established models. In academic forums and public debates, voices were raised, and defensive stances were solidified. The discussion transcended the specifics of Oumuamua or Atlas. It became a fundamental inquiry into the very soul of scientific endeavor. Was it an unwavering pursuit of truth, or a mechanism designed to maintain existing certainties? Loeb's composed defiance echoed the defiance of Galileo, confronting the formidable authority of the Inquisition. He did not claim to possess divine revelation, but merely asserted his fundamental right to engage in open speculation. When nature presents us with empirical evidence that deviates from our established frameworks, he posited, we must expand our imaginative scope, not restrict our definitions. The ensuing controversy illuminated a rarely acknowledged aspect of scientific pursuit: its susceptibility to human emotion. Pride, apprehension, and professional reputation exert considerable influence on the quest for knowledge. In an environment where research funding is often contingent upon consensus, and career advancement is frequently tied to conformity, the simple act of intellectual curiosity can become a form of quiet rebellion. This undercurrent of rebellion was palpable in Loeb's pronouncements, in every late-night observation session, and in the measured cadence of his voice. To him, faith and doubt were not adversaries, but essential partners in a shared intellectual dance. He once observed that placing faith in reason itself is ultimately still an act of faith. The Galileo Project evolved into a refuge for individuals who embraced this fundamental conviction. Younger researchers, unburdened by the ingrained caution of more established institutions, found within its collaborative spirit a space to pose questions previously deemed unconventional. They scanned the heavens not solely in search of empirical proof, but for a form of validation, permission to experience astonishment once again. For the general public, Loeb emerged as an icon of audacious intellectual pursuit. His essays and interviews tapped into a primal human yearning, a deep-seated desire to be part of a narrative grander than our individual existence. Yet, beneath the eloquent prose lay a starker reality. The pursuit of genuine discovery invariably demands a degree of discomfort. To confront the unknown and acknowledge one's own ignorance is not an indication of weakness, but rather the very genesis of profound wisdom. Within the data analysis centers of astronomical observatories, as terabytes of light data streamed in from 3i Atlas, younger scientists began to articulate their own nascent, almost heretical thoughts. What if his intuition is correct? What if this object represents the singular event we've been seeking? What if our entire approach to observation has been fundamentally flawed? While no one dared to commit such thoughts to formal publication, in the quiet moments between complex calculations, a flicker of hope began to reemerge. It was the kind of hope that the academic establishment too often dismisses as mere naive optimism. Perhaps Loeb's most significant contribution was not a tangible discovery, but a profound act of restoration. He reminded the scientific community of its primordial impulse, the very yearning that inspired Newton under the apple tree, propelled Einstein to conceptualize the speed of light, and compelled Galileo to direct his telescope towards the heavens, challenging established dogma. The pursuit of meaning within the cosmos is not an abandonment of rational thought. Rather, it is a remembrance that reason itself originates from the fertile ground of wonder. And as the debate intensified, as critics honed their arguments, and an unending stream of data flowed from the celestial sphere, one fundamental truth remained constant. The universe itself remained indifferent to the outcome of human discourse. It persisted in dispatching its messengers. This perhaps explains the quiet smile that played on Loeb's lips when questioned about the criticism he faced. In the final analysis, he stated, "Truth possesses no allegiance. It simply awaits discovery." And above him, as invariably occurs, the act of waiting continued, vast and silent, permeated by the radiant shimmer of infinite enigmas. What if the celestial expanse is not merely a stage for impersonal physical forces, but rather a field imbued with deliberate intent? What if the faint glimmer emanating from Three-Eye Atlas is not an accidental aggregation of terrestrial matter and frozen gases, but the residual echo of a sentient mind, a purposeful construct adrift eternally through the cosmic darkness? This is a question that challenges the very foundations of scientific inquiry, yet it resonates deeply within the realm of poetic expression. However, as the data pertaining to Atlas becomes increasingly granular, the distinction between these domains begins to blur. Even the most rigorously disciplined scientists, those whose lives are governed by the unyielding certainty of numerical values, begin to experience the subtle tremor of speculative thought. Imagine, they whisper amongst themselves, if it were demonstrably true, if the collected data revealed an unmistakable geometric precision, a consistent symmetry in its form, or a predictable repetition in its rotational patterns, would that not unequivocally imply deliberate design? If radar imaging were to detect edges too sharply defined for random cosmic processes, or materials utterly unknown in natural geological formations, would that not serve as an undeniable signal, even in its silence? What would be the practical implications, moving beyond purely philosophical contemplation, if advanced alien technology had traversed our solar system entirely unnoticed, unannounced, and unmolested? For some, this realization would signify that the universe has already communicated its presence, and humanity simply lacked the capacity to perceive it. For others, it would represent the dismantling of centuries of profound existential isolation. Loeb has frequently articulated the notion that the discovery of intelligent life does not necessarily mandate direct contact. Rather, it hinges upon our capacity for recognition. If an artifact navigates our skies, he reasons, we need not intercept it to grasp our non-solitary existence. Its mere presence would speak with greater resonance than any deliberate message. The potential ramifications are boundless. Certain theoretical frameworks propose that interstellar artifacts might not function as conventional vessels, but rather as autonomous, self-replicating entities. Von Neumann probes engineered for exploration and propagation. Other hypotheses envision ancient solar sails, remnants of long-extinct civilizations, their technology drifting as cosmic fossils through the void. Yet others speculate that such objects might possess a form of existence entirely beyond our current comprehension, not biological in nature, but computational and sentient, conscious machines engineered to endure the cataclysmic demise of stars, carrying fragments of thought across the galactic expanse. Should 3i Atlas exhibit even the most subtle indication of such intelligence, the repercussions would extend far beyond the confines of astronomical study. Every discipline, physics, biology, theology, philosophy, would experience a seismic shift. Religious doctrines would confront the profound realization that creation is not a singular event. Philosophical discourse would grapple with the concept of consciousness divorced from organic form. Physics would probe the mechanisms by which technology might endure the passage of time itself. And humanity, vulnerable yet proud, would be compelled to confront a profound and unsettling humility. Perhaps this is the very source of the current apprehension. Not the mere possibility of extraterrestrial life, but the absolute certainty of a dramatically altered perspective. If such intelligences exist, then humanity is no longer the ultimate measure of all things. We are but a single note within a far grander symphony, a composition that commenced long before our instruments acquired the ability to discern its harmonies. Loeb, while firmly rooted in the principles of reason, is not oblivious to this profound emotional gravity. He often speaks of the cosmic mirror, illustrating how the quest for extraterrestrial life ultimately serves as a reflection of our own deepest fears, our innate hungers, and our pervasive sense of solitude. The discovery of alien technology would not merely alter our factual knowledge. It would fundamentally transform our very identity. What would be the impact on human civilization if it were to learn that it is observed that another intelligence, either in the past or present, has reached this same cosmic shore? Would we succumb to fear, or would we ascend to a new level of universal wonder? Historical precedents offer glimpses into potential responses. Every monumental revelation, the spherical nature of the Earth, the orbital mechanics of the planets, the sheer immensity of the cosmos, initially challenged human pride, before ultimately expanding our understanding. It is plausible that this paradigm shift would follow a similar trajectory. 3i Atlas may ultimately prove to be nothing more than a natural geological formation. However, if it is something more, if it is an artifact, ancient and deliberately crafted, then it also represents an invitation, a potent reminder that intelligence, wherever it flourishes, shares a singular, universal instinct, the drive to explore. And perhaps eons ago, on a world orbiting a distant star, an analogous sentient being gazed at its own nocturnal sky, perceived the faint luminescence of our sun, and mused whether a presence awaited it there as well. If this scenario holds true, then 3i Atlas is not merely a discovery. It is, in essence, a reunion. The deeper humanity ventures into the cosmic unknown, the more acutely it perceives its own mirrored image. Every telescopic apparatus functions as a reflector. Every captured image of a remote star serves as a portrait of humanity's profound longing. The pursuit of other intelligences has always, at its fundamental core, been a quest to understand ourselves. As 3i Atlas continues its silent passage through our solar system, gradually receding into the profound darkness of the outer void, the scientists who have meticulously charted its trajectory begin to realize that their inquiries have transcended the object itself. They now pertain to meaning, to what this extraordinary pursuit reveals about the species that embarked upon it. R.V. Loeb frequently asserts that the universe is under no obligation to conform to our understanding, yet we persist in our attempts to comprehend it. Each anomaly, each inexplicable flicker of light, each deviation from the ordinary becomes an act of cosmic dialogue, a means by which we communicate to the universe. We are attentive. We are prepared. And within this state of readiness lies a profound paradox. The more fervently we seek evidence of other intelligences, the more clearly we delineate the contours of our own inherent nature. Every data point we pursue betrays our deep-seated need for belonging, not merely to a terrestrial planet, but to a narrative that transcends Earth, that surpasses the boundaries of life itself. Perhaps this is why the mere possibility of extraterrestrial technology evokes a sentiment that extends beyond the realm of pure science, a quiet, pervasive ache for connection, a yearning that surpasses the constraints of empirical validation. We aspire to know that intelligence is enduring, that consciousness is not a fragile ember destined to extinguish in the darkness, but rather a potent force capable of transcending the limitations of time and spatial distance. Even the stance of skepticism is an integral component of this fundamental human hunger. The unwavering insistence on verifiable evidence, the rigorous application of doubt, these are, in their own way, expressions of profound reverence. The skeptic, much like the devout believer, bows before the immensity of the unknown, demanding irrefutable truth rather than comforting illusion. Both stances represent profound manifestations of awe. When Loeb speaks of the cosmic mirror, he does not allude to a literal physical reflection. He implies that the exploration of the unknown ultimately reveals our true character when we believe ourselves to be unobserved. Do we approach the enigmatic with arrogance or with profound humility? Do we greet the unfamiliar as a potential threat or as a kindred spirit? Within the sophisticated laboratories and vast observatories meticulously tracking Atlas, this metaphorical mirror reflects most brilliantly. Its luminescence is discernible in the quiet, unwavering dedication of a graduate student meticulously calibrating a telescope, in the sleepless hours spent analyzing complex spectral lines, and in the electrifying thrill of detecting a signal that could be mere random interference or, potentially, a pivotal moment in history. For centuries, scientific endeavor has represented humanity's form of supplication, not through spoken words, but through sustained, focused attention. To study the vastness of the universe is to humbly acknowledge something immeasurable, to meticulously trace its intricate patterns with trembling hands, and to whisper a profound plea, "Reveal to me the essence of my own being." Atlas, irrespective of its origin, whether natural or artificially constructed, has achieved precisely this. It has presented humanity with a reflection captured in the distant starlight. It depicts a species that resolutely refuses to cease questioning. A species that engineers sophisticated instruments solely to extend its own perceptual capabilities. A species that experiences a profound sense of cosmic loneliness across unimaginable distances, yet still perseveres in reaching outward. In any event, perhaps the most significant message conveyed by these interstellar visitors lies not within their physical structure or their celestial trajectory, but rather in the profound manner in which they reawaken our courage to embrace the spirit of wonder. Each sighting, every ensuing debate, every unanswered query serves to rekindle a fundamental human drive that predates civilization itself. The innate desire to comprehend our position within the infinite expanse. And perhaps, just perhaps, that is the ultimate purpose. It is conceivable that these visitors are not emissaries from other worlds, but rather reflections sent back across the void to remind us of our inherent potential, of who we were always destined to become: explorers, dreamers, and attentive listeners. The universe, after all, may not be characterized by silence. It may simply be exercising extraordinary patience. As 3i Atlas gradually recedes into the perpetual night, the flow of incoming data diminishes, the cacophony of speculation subsides, and the celestial sphere reverts to its tranquil, ever-present hum. Yet, something fundamental has irrevocably shifted. This transformation has not occurred in the distant cosmos, but rather within the human consciousness. Humanity has peered into the profound darkness, and for a fleeting but transformative moment, perceived itself illuminated by the faint, ethereal light of boundless possibility. The cosmos remains immense, seemingly indifferent, and eternally enduring. However, it somehow feels more intimately connected than ever before. This is because we now understand that when we gaze into the profound unknown, it gazes gently back, not with the intent to instill fear, but to gently remind us that the capacity for wonder represents the most universal language shared by all forms of intelligent existence. The heavens once again fall silent. The monumental instruments have completed their assigned tasks. The telescopes have diligently tracked, the sensors have meticulously measured, and the sophisticated algorithms have processed every individual photon. 3i Atlas continues its slow, deliberate retreat towards the outer reaches of our solar system, its luminescence gradually diminishing with each passing week. And humanity, having followed its journey as far as the constraints of light permit, now finds itself suspended in the quiet interlude between profound questions. The period of waiting commences. Within the confines of laboratories and control rooms, the monitoring displays no longer flash with constant urgent updates. The continuous streams of incoming data have thinned to mere trickles. The calculated coordinates no longer exhibit significant changes. All that remains is the meticulous process of analysis, the painstaking comparison of theoretical models, the ceaseless calibration of inherent uncertainties. What remains unspoken, yet palpable, is the underlying emotional current. Scientists rarely articulate their hopes explicitly, yet it lingers in the atmosphere, immeasurable and undeniably present. They harbor the sincere hope that once the numerical evaluations are finalized, something inexplicable will persist, a residual trace of the impossible, a detail so precise that it defies any attribution to random natural processes. However, science is characterized by its inherent patience. It understands that truth is not revealed in sudden flashes of insight, but rather through sustained investigation and enduring examination. The dedicated teams meticulously sift through the accumulated data. Each recorded light curve, each spectral signature, each pixel of captured sunlight is subjected to rigorous dissection and simulated analysis. Powerful computers construct models of Atlas's form based on its fluctuating luminescence, testing every conceivable possibility. Is it a tumbling fragment of rock, a remarkably thin plate, or a highly reflective disk? The models continuously shift and reconfigure, akin to tentative guesses made in profound darkness. None of them achieve a perfect fit. On some days, the analytical findings suggest a straightforward rocky object, irregular, but naturally formed. On other days, the explanatory power of the model improves significantly only when an unnatural degree of symmetry is introduced into the analysis. This could manifest as an unusual flatness, a distinct sheen, or an improbable overall balance. The conclusive answer oscillates precariously between absolute certainty and persistent doubt, as if the very truth itself is reluctant to commit to a single, definitive interpretation. The media coverage surrounding the phenomenon has also become notably quieter. The initial frenzy of public speculation has cooled into a pervasive atmosphere of patient anticipation. And it is this prolonged state of waiting that, it turns out, proves to be a far greater challenge than the initial sense of wonder. Avi Loeb, now accustomed to the cyclical rhythm of public fascination and subsequent disinterest, retreats once more into a period of quiet contemplation. He dedicates long evenings to poring over data printouts illuminated by the solitary glow of a desk lamp. This scene serves as a modern echo of Galileo, who, centuries prior, meticulously studied the celestial bodies through his rudimentary telescope. The world once ridiculed Galileo's findings, yet the Earth steadfastly continues its motion. To Loeb, this silence of definitive confirmation is not a source of discouragement, but rather a deeply satisfying melody. He quietly conveys that we exist in the interim between new insights. For every enigma that remains unsolved, another emerges. Researchers are conceiving of novel expeditions, swifter craft, specialized orbital platforms, and infrared detectors designed to precisely document the subsequent visitor from beyond our solar system in extraordinary clarity. The blueprints are already taking form. If not this endeavor, then the next will succeed. Humankind is not only learning to perceive, but also to anticipate. Within this period of waiting, something profound is unfolding. Across diverse fields and among various generations, scientists who once dismissed Dr. Loeb's concepts are now beginning to adopt his terminology. They cautiously discuss techno-signatures and deliberate with measured impartiality on the potential for extraterrestrial artifacts. The barriers of mockery are beginning to erode, replaced by something else. It represents the gradual, unperceived triumph of an idea whose moment has arrived. However, for the present, Atlas recedes, a faint trail of movement on the verge of observability. In a few months it will vanish, too distant even for our most powerful telescopes to detect. Another emissary departs into quietude, yet its journey leaves an imprint, not in quantifiable data, but in our changed outlook. Humanity has once again gazed into the celestial expanse and discovered it is not devoid, nor uncaring, but teeming with activity and enigma. Every unresolved query carries significance. Every instance of quietude serves as a form of communication. The universe communicates not through conventional language, but through observable phenomena. Each anomaly functions as a single unit of meaning within a narrative we have yet to decipher. The researchers persevere in their work. Life continues on Earth, but somewhere beyond our visual range, a small entity, whether naturally occurring or artificially made, drifts among the stars, carrying the testament that humanity once took notice. The ensuing quiet is not an absence of everything. It is a state of expectation, the prolonged, gentle inhalation preceding a revelation. This is because within the scientific pursuit, silence is never a finality. It is the space where significance accrues, remaining hidden until someone possesses the courage to listen once more. Darkness descends upon the astronomical observatories. Screens dim, telescopes are housed beneath their protective coverings, and the stars resume their perpetual, steady cadence. Patient, vigilant, ancient, the spacecraft Atlas has now passed Jupiter's orbital path, a barely perceptible gleam too faint to track. What endures are the collected records, vast quantities of information, mathematical expressions noted in the margins, and a single persistent question that no current computational method can yet answer. Avi Loeb, once again, stands beneath the sky that has shaped his existence. Above him, the Milky Way sprawls in gentle streams of luminescence. Each star is a remembrance of possibilities that might have been. Each period of silence holds a promise of what may still unfold. He understands that scientific inquiry, much like the universe itself, does not offer definitive conclusions. It provides a sense of continuity. The Galileo project proceeds with even greater momentum. Its telescopes scan the heavens in anticipation of the next arrival. Its databases are accumulating new patterns of light and motion. Perhaps a fourth interstellar envoy is already en route, navigating the void, unconcerned with the small, blue planet that awaits its appearance. However, the significance of the third envoy, Atlas, extends beyond its recorded data. It is not about definitive proof, but about unwavering dedication. Humanity has learned that the very act of observation is an expression of trust. Trust in empirical evidence, trust in comprehension, and the trust that the universe, regardless of its immensity or apparent indifference, will eventually respond. Dr. Loeb frequently reflected that the endeavor to find extraterrestrial intelligence is not a search for others, but a search for meaning. He once wrote that every instance of curiosity is an outward manifestation of hope. To gaze at the nocturnal sky and ponder if someone else once did the same is to acknowledge our connection to something larger, a cosmic lineage of individuals who refused to succumb to stillness. And perhaps that itself is the ultimate revelation. The message was never inherent in the object itself, but in the reaction it elicited. The collaborative efforts of scientists, the healthy skepticism of doubt, and the quiet bravery of those who dared to inquire. Atlas, whether a natural phenomenon or an engineered construct, impressed upon us that discovery is not about reaching a destination, but about a profound awakening. The universe remains silent, but it is no longer empty. It resonates with unanswered questions, alive with potential. The investigation continues not because we anticipate a definitive answer, but because we are compelled to keep asking. That is the essence of being human. To stand beneath the infinite expanse and utter, "Reveal yourself to me." And when the next interstellar visitor arrives, as it surely will, humanity will be prepared. Not merely with advanced instruments, but with the understanding that the very process of seeking has already transformed us. The cosmos has not altered. We have. The sky above stretches out, a vast, dark sanctuary adorned with stars. Somewhere out there, another traveler glides, carrying the radiance of its point of origin. And here, on this small world, we watch and await. Our instruments are silent, our hearts beating with a fervor more potent than ever. For even in the quiet, the dialogue persists. The universe inhales and exhales. The narrative unfolds at a measured pace. Words soften like light diffusing through water. The intricate mechanisms of scientific endeavor settle into a tranquil state, leaving only the fundamental rhythm of the earth beneath the heavens. Somewhere beyond the constraints of time, a piece of alien rock or perhaps a figment of our collective imagination, navigates the interstellar void, unhurried. Its trajectory will span millennia, traversing regions of space that no eye will ever witness, no intellect will ever map. Yet, for one fleeting instant, it passed close enough for us to perceive, close enough to awaken our ancient urge to connect. The cosmos remains as it has always been, immense, silent, beyond full comprehension. But we are no longer the same. We have peered into its depths and perceived both its mystery and our own likeness within it. Perhaps that is sufficient. Let the stars continue to hold their secrets for a while longer. Let the quietude preserve its profound implications. For in our pursuit, we have discovered what every civilization must eventually ascertain, that wonder itself is the closest approximation we possess to an eternal state. The telescopes close their lenses. The night reclaims its silent dominion. The question, still unresolved, lingers in the darkness. And somewhere, softly, the universe seems to whisper back, "Rest peacefully."